The flow of fluid through a pipe is resisted by viscous stress within the fluid and turbulence that develop along the internal pipe wall when a gas or a liquid flows through it. Because energy is necessary to resist the because of frictional force produced on the flowing fluid by the pipe walls, there will be a loss of pressure in the fluid.
Assalamualaikum, my name is Tuan Muhammad Farhan, matric number DD 2007-9. I'll continue to the observation parts. In this experiment, we can observe that differential heat can be obtained by opening the needle valve. Next, 300 ml water collected from the overflow pipe becoming slowly respected to time recorded. Thirdly, the water level needs to be stable before taking the recording of H2. Furthermore, when we open the bench supply water clearly to provide a constant head to pipe under test. Therefore, the flow of water will be steady accordingly. Last one, the needle valve is very sensitive, so it is need to be operated patiently.
Hi, Assalamualaikum. My name is Muhammad Anwar Rashidi bin Nur Azmi. My matric number is DD 2082. Okay, so my objective for this video is to present about the calculation that we do for the experiment, group experiment report. Okay, so for this report, we need to calculate a few things such as volume flow rate, velocity, hydraulic gradient, which is I, and then the log of I, and then F, the log of F, and then the Reynolds number, also the log of Reynolds number. Okay, so firstly we start with volume flow rate, which is Q. Q equal to volume over time. So volume for the every recorded data is 3 times 10 to the power of -4 over time, which is time is our recorded data. So by divide the volume with time, we get the volume flow rate value. So for the velocity, by the formula of V equal to Q over A, Q is the volume flow rate that we get from above, and then the area is the area given, which is 7.069 mm square. So there we will get the value of velocity for every data. And then the hydraulic gradient I equal to H1 minus H2 over L. H1 and H2 is we get from is the data that we recorded during the experiment. So we just using the data recorded, H1 minus H2 over L. L is given initially. L is 524 millimeter. Okay, and then for log of I, just insert the value of I that we get from above, and then we'll get the value of log I. And then same goes with F. F, by using the formula of I equal to 4F over D times V squared minus 2G, we derive the equation to get F equal to I dG over 2V squared. And then we insert all the values that we have to find the F. And then for log of F, we will, for the log of F, just insert the value of F that we get from above, and then we will get the value of log F. Okay, and then lastly for Reynolds number, we're using the F equal to 0.079 times RE to the power of -1/4. Okay, and then we derive the equation, we will get RE equal to F over 0.079 to the power of -4. And then just substitute the value of F that we get from the data above, and then we will get the value of Reynolds number for every data. Okay, and then for the log of Reynolds number, just insert the Reynolds number that we get from the above, and we will get our log of Reynolds number value. Okay, so that's all for the calculation part. Hi, Assalamualaikum. Okay, now I will continue about the discussion for this group report. Okay, so the first discussion that we need to discuss is the result of the graph. Okay, for graph 1, the graph I against V is in linear with positive gradient of 0.997. And then the hydraulic gradient, which is I, increase as the velocity V increase. And then for graph 2, the graph of log F against log RE is in linear pattern also, but with negative gradient. And then the value of log F is decreased when the value of log RE is increased. Okay, for the last graph, graph 3, the graph of log I against log RE thus shows a curved linear graph with a positive gradient. Okay, so that's all for the graph that we draw for that we sketch for the data that we need. Okay, so for the second discussion that we need to do for this group report is that we need to derive the equation of I equal to 32 times V, which is the kinematic viscosity, times V, which is velocity, over G d squared. So we need to make the kinematic viscosity as the subject. So when we change the placement of the other things, we will get V kinematic viscosity equal to I times G times d square over 32 V velocity. Okay, for the next discussion that we make in this group report is to insert the slope value I over V to get the theoretical value of kinematic viscosity. So we substitute the value of experimental value of I over V first into the formula of I over V equal to 0.97, and the formula of V is V equal to I over V G d squared over 32. Then we insert the value of I over V of experimental value, and then we will get 2.751 times 10 power of negative 6 meter square per second. So that is the value for experimental value. So for theoretical value is 1.679 times 10 to the power of negative 6 meter square per second. So here we can see that the experimental value is higher than the theoretical value. Lastly, for the discussion, we need to explain the effect of friction F due to the flow change of the Reynolds number from laminar to transition. So the thickness of sublayer decrease as the number of Reynolds number increase. So the surface bumps into the sublayer, and then the higher the roughness of the pipe, the lower the value of Reynolds number, which the curve of at the graph F versus Reynolds number branches off from smooth pipe curve. And then the friction factor for smooth pipe decrease more rapidly with the increasing Reynolds number than for the pipe with compared to rough walls. So the internal surface of a pipe is said to be independent at the diameter. Okay, so that's all for the discussion for this report. Thank you.
As the conclusion, the experiment's objectives have been met. However, the outcome of the experiment is incorrect due to experimental and theoretical values disagree. From the experiment, we can conclude that the linear pipe with rough surface having larger energy losses than the smooth surface. This occurs because friction in rough surface pipe is higher than the friction in smooth surface pipe. From the experiment, we also know that losses in pipe are also dependent on the diameter of the pipe. The smaller the diameter will have greater losses. Besides, losses in pipes are also dependent on the flow rate. When the flow rate is higher, losses will also be higher. So that's all from me. Thank you.